provide us something, we transform them into data structures. And so that is how we do the search later on. So text analysis makes your text kind of like full text searchable. Now remember, full text searchable is not talking about apple to apple match. It's just talking about like this search term, does it appear inside your final text and final text description? All right. So that's the text analysis thing. Okay. So take example, if you provide us like United States, right? We actually will break it down into two words, United and States. Also, we will do some processings like lowercase them, etc. All right. So that's the idea about text analysis in general. So on the other hand, your query string will also be analyzed in the same way. So if you provide me some other words for searching, right? You will also go through the same analysis chain and get back a bunch of tokens. So then after we have the tokens, we'll use all the tokens to do a token level matching. If something matches, no matter which token it is, we make that document as a hit. So that is the so-called mechanism. And by default, we do ship you a bunch of different analyzers. For example, we have the some basic language analyzers. We have the default standard analyzer. We have white space, stop, and some pattern-based analyzers, right? So all these things are shipped in. And if you want, you can actually make use of it to analyze your string data, all right? So in some further discussions of this class, we'll actually talk about some of these analyzers, for example, standard and some language analyzers in general. Now, for most cases, the Boolean analyzers will work for your use case, all right? So because by default, we are using something called standard, okay? So this standard analyzer is already there, and we are using it nearly for all the string fields till now. Because by default, if you didn't set any setting level change, we'll be using this analyzer. And you already found that no matter, like for example, the United States thing, right? If you give me something like this, United States, it will also be searchable. All right. The reason is because this standard analyzer provides some very basic means for us. For example, just do the tokenization based on non-alphanumeric characters. So that's why you get back two words eventually. All right. And also we do lowercase to U. So you can see now, no matter it's a big United or maybe lowercase United or maybe mixed case, they all will be lowercase eventually. All right. And we also have stop words, but we will deactivate by default. So that's why for in this case, we still get back all the tokens without missing anything. So that's the idea. So that means even though we didn't really learn what is analyzers, we've already been using it, especially on string fields, right? So that's why we say for most of the cases, the Boolean analyzers are already great for your most situations, right? Unless you have some very specific use case. For example, I want to do some matching. Now, take example, we can apply something like aliases. And so one of the use cases that I have gone through is, take example, there is actually a medical company, for example, related to creating some medicines, that kind of thing. So you know that in medicines, right, or maybe in the field of chemistry, we have a lot of chemical formula names to describe a substance. So take example, water. So in the chemical formula is actually H2O, right? So that's why in some of the cases, because that's a medical company, right? So they are using medical formula names instead of the human understandable names. For example, H2O, CO2, something like that, instead of carbon dioxide. So that's why in their data, the original data are all related to formula names. And for the outside world, if they want to expose their data set to the outside world for searching, people probably do not know the formula names. For example, how do you know that water is H2O? Unless you have gone through the chemistry class before. So that's why they need to do an analysis operation. And this analysis operation involves mapping certain formula names into human understandable words. For example, when I map something like H2O, it'll be transformed into a alias word called water as well. So that's why now, no matter later on, if inside the search bar, if people are just typing water, they can still get back the documents related to H2O. All right. And on the other hand, if you are actually also a doctor or a chemist, you also know H2O as the formula, you can still type in H2O. You can still get back those water related documents as well. So these are some of the additional use cases that you might need to change. But in general, I would say for very simple use cases like just normal English word searching, actually it's okay. You can just use the standard, right? That should be good enough. All right. But anyway, we just let you know that you can also customize your analyzers. And customization is kind of like covered in the next class, Engineering 2, instead of this one. Okay, so just let you know that what kind of things you can do. And if you're interested in it, you can either join the class later on, or maybe you just go to search in our official documents on how to customize or make customizations on the analyzers. So in general, then we know that there are analyzers, right? But where do we actually kind of like set up this thing to a particular field? I mean, how to associate it. So in general, inside our mappings, there should be an optional parameter called analyzers. So take example here. You can see that I've indexed all my blocks. I've got some mappings, of course, and underneath I've got a field called content. And so if you didn't set anything about analyzers, it will be using standard, all right, the default one. But if you think that this content should be analyzed in another way, you can actually change the analyzer by putting the analyzer name here. Take example, using the English way, okay? So that's exactly how we change the behavior of the text analysis. So now, why do we actually have two types of strings then? If you still remember at the very beginning, we told you that there is a text, there's a keyword. So why do we need two types of string then? If you still remember on day one, I've already told you that strings, we actually have two types of search use case. The first one is identical match, apple to apple. All right, they must be exactly the same. So this is when we need to have a keyword, okay? Exact matching. So on the other hand, for text, it's talking about like you give me some keywords, all right? And are they available inside this big message here? All right, and this big message can be some thousands of words inside. So when we talk about this kind of search, we're talking about something like how relevant it is. All right, so that's why text is for what we call full text search. Or you can just kind of understand is it, does it occur? Okay, so does it occur inside that big passage? All right, if that's the case, good. All right, so we'll bring it out. And so you can guess, right, for keywords, usually there is, well, there might be a score, right? But usually we don't need a score because we're talking about apple to apple. So if it matches exactly, of course, it should be there. If it doesn't match, maybe one character difference, it will not be inside a result set. So that's why for keyword, that kind of exact match, for most cases, score is not that important. But on the other hand, for full text searches, we're talking about how relevant it is, this word versus this passage. So we're talking about the scoring. And the bigger the score, the more relevant it should be. And again, just a reminder, if you understood and remember the calculation algorithm, we're using TF-IDF. And TF is talking about how many occurrences, right, of that particular word inside that whole final message. And so that's why there should be a score related to this kind of search as well. All right, talk about relevancy. So that's the short explanation. All right. So inside the slides here, we actually will kind of like re-talk about it in another way to provide a kind of like example. Now, sometimes when we talk about the country names, right, these strings should not be analyzed. The reason is because if we analyze the names of the countries, you will actually get back two different words for United States and United Kingdom as well, right? So you can find that if you got a country called United States or another country called United Kingdom, once we do analysis on them, it will break into two pieces. The first word is United. The second word is either states or kingdom. Now, this is the interesting thing, because when we try to do aggregations, right, if you break that country name into pieces, like pieces of two, you actually should get back two values for the aggregations as a count, because United is one entry, states is one entry, kingdom is another one. To be honest, this doesn't make sense because United States should be one single phrase, all right, instead of breaking into two pieces. So that's why for this kind of situation, we do not need a analyze the string. So typically, we just need a keyword. We need exact matching, something like a phrase, right? And so that is exactly why we have two use cases as well. So for aggregations, instead of searching, sometimes we also need to have the original phrase available for doing any statistical operations like counting or averaging, that kind of thing, right? So that's why we need keyword as well for certain use case like sorting, aggregations, and so on, all right? So this slide is kind of like repeating what I was talking about just now. So remember, text fields, they are all analyzed. We need the tokens, and then we use a token level matching and check the relevancies, all right? For keywords, they are usually not analyzed, all right, unless you do something called normalization. And it stores the original values of the strings so that we can use them for aggregations, like counting how many United States, how many United Kingdom, doing sortings because we have the original values, and also finally the exact matching as well. So apple to apple match with all the punctuation marks, the spaces, and also the upper lower case totally matching. All right. So these are the reason why we still need to have a keyword field sometimes, right? Later on, we'll have a short discussion. Is like, does it mean that then every kind of string data you provide to me, we need to have both keyword and text? Okay, well, so we'll have that discussion later on. But the idea is typically no. All right, so we'll actually decide on the behavior of this data. Should they contain something like a text field and a keyword field, or just one of them, right? Anyway, we'll just go through that a bit later. So next topic is talking about multi-fields. Now, multi-fields, we've already gone through that because all the string data by default, if you didn't do any setups or mappings, you should be returning a text field plus a keyword field for you. So the keyword field is what we call the multi-field. So it's kind of like a parent-child, all right? So the parent by default is always a text field, and the corresponding child is a keyword. So that's why if you provide me something like a string like this, like country name, so in this case, country name will be the text field, okay? And country name dot keyword will be the keyword field, all right? So this is the default handling if you do not set up anything beforehand, all right? Because we guess the mappings for you. And again, because we want to play safe, we do not know what we would do to this string. So we usually will give you a text and keyword, okay? So again, just to play safe. So we always guess this kind of mapping for you. But of course, it might not be optimal because later on we'll discuss some fields actually do not need a keyword. Some fields do not, on the other hand, need a text field. So then if we just kind of like take a look on the default mappings for most of the indices, you'll find that for the string fields like country name, you should have a text and then a subfield called keyword. So this is the syntax. There's a thing called fields, and then you provide the subfields name or label. So here we give it keyword as well. It's a little bit confusing, I know, because the type is also keyword. So in the old days, when we are still using version 2 of Elasticsearch, we call this the raw field, RAW. Okay. So if you're kind of like me using Elasticsearch for some time, you can actually name this field as raw instead of keyword. All right. But for the latest convention, naming convention, starting from version 5, we already been using keyword. All right. So anyway, just to let you know, because this label is kind of arbitrary. It could be anything. All right. So now the discussions comes again, right? So do I need to have both text and keyword for every single string? The reason is no. All right. The first thing is before logically understanding why it is a no, we have to understand that physically it will slow down our indexing because you are creating two fields for this single string. So each field will create a data structure itself. So we're talking about the data structure on the next lesson. So that's why if you have every string field has a text and keyword, you're creating double data structures to hold those uh, values for us to do the matching. So that's why it will kind of like slow down your indexing a bit. And also it makes use of more of this space as well because you're storing things in the disk level eventually. Remember, each field has a data structure. So all the data structure will occupy some space. So now logically, why don't we need to have all these text and keyword then? The reason is because some of the fields, you just need them to be full text searchable. Now take example, the content field. For content field, it's a very lengthy message or passage, right? It could be some hundreds of words. So what's the point to have a identical match? So take example, if you were the user, you're using a system, will you be able to remember every single word inside that particular product or blog? Probably no, right? You just remember some keywords. For example, this blog was written for Logstash. And then there should be somebody called Shy Bannon introducing Logstash, for example. You just remember a few key words or key person's name. And then you type in the search bar and you're expecting to get back that message in the listing. So that's why for this kind of free text fields like content, description, that kind of thing, we just need a text data type because we're going to do a relevancy search instead of like apple to apple exact matching because it's nearly impossible. All right. So what about some other fields like for example locales? So pretty much locale should be a keyword field only. The reason is usually locales that kind of categorical data, you provide a UI. And this UI provides you the drop-down box or maybe some selection, combo box, that kind of thing, so that you can actually select the corresponding locale instead of like you type the locale inside search bar. All right, so that doesn't make sense, right? So take example, if you want to get back something from written in Japanese, all right, would you actually type in the locale JPJA, something like that? Probably no. You would actually select the language. All right, so the language might be coming from some combo box, and then you convert it into the Japanese web page, blah blah blah. So that's the point. So usually for this kind of categorical data, we will use keyword only instead of using a text field. All right. So that explains why some of the string fields we need only one particular type. Okay, so finally, there are some strings that require both of them, like your full name. Now, take example. Our boss is called Shy Bannon, right? To be honest, even to me today, I sometimes have his name spelled wrongly. So I might say something like this, double N instead of single N. So that's the point. So even though I know how to read his name, how to pronounce his name, but when I type his name, it might not be 100% typo free. All right. So that's why for this kind of situation, we should provide a text field. Okay. The reason is because text field, even though Bannon is incorrect, I still got shy, this word, SHAY, matchable. So I might get back a list of shy, like Shy Bannon, Shine Christopher, something like that. I still get back this list possible. And then I can kind of like still look into it and select the right person. All right. And on the other hand, if we want to do sortings, like for example, grouping or sortings of the blocks written by who, we can actually use the keyword field because we're talking about the exact name and group all those blocks together under that name. And then we can do calculations like sorting or maybe something like aggregations, counting how many blocks written by this person, that person, etc. So that's why for full name, this kind of fields, we actually would need to have both because there is a chance that people are trying to search for a author. He or she might not know the full name, how to spell correctly. So we need a full text search to kind of like grab out all the related documents first. And on the other hand, you might also want to sort or maybe group those blocks based on usernames. And so if we want to do this kind of operation, you must have a keyword. All right, so that's why for some strings, we need both. So the last point, optimize your mapping to support your use case. Here means that you as the data owner, you need to understand the behavior of the data. If you understand the behavior, you would know this kind of string only needs what data type. Okay, so this is what we try to tell you here. Okay, so be kind of like, work on it, all right? Work on some of the behaviors of the data. Then you know exactly what data type it should be. Also later on, if you're going to engineering 2 this class, you would also need to know is like, if you get some special fields, how do you kind of like reanalyze them to make sure that your use case are fulfilled. So that's why you need to pay some work effort to know your data. And for this one, I can't help you because I'm not working in your company. So I do not know what your data should behave, right? Instead, you or the business analyst in your company should know these things, right? Even though I think in real life, I wonder if they also know it, right? But anyway, that's another story. So that's why to optimize your mappings, after understanding what fields or behaviors these strings are, you can start to change those mapping setups. Take example, message is a free text field. So I just need a text, no keyword, right? For HTTP version, because it's a categorical value, so either 1.0, 1.1, or maybe 2.0, that's it. So only 3 values, right? So in this one, it should be a keyword. Now, on the other hand, country names, because people might be typing the country name, maybe they have typos or whatever, so I need a text field. On the other hand, the keyword fields are also required because we want to sort the results based on country names, all right? So that's the reason why we need to have both data types for this particular field. All right, so now before we actually go into the final conclusions, that kind of thing for this lesson, let's have a short demonstration on some of the APIs. So these are extra things, right? We usually don't talk about this in Engineering 1, but since you might not be joining Engineering 2 later on, so let's have a short demonstration on some useful APIs. Okay, so now we're back into this Kibana Dev Console. All right, so the first thing I need to kind of like guide you is how to get back the mappings, right? Now, big example, I've got the blocks here, right? So we can do a search as usual like this, right? Very happy. So how do we know the mappings and settings of this blocks index then? Simply, you type get index name and run. You'll see that we will be returning something called blocks and then the corresponding aliases, the mappings here. Okay, so this is what we want to know. And then also some settings if available. So you can see here, this index is having 1 primary shot and 1 replica shots, right? So exactly something like this. Now, this is not what I want to tell you. I want to show you the mappings instead. So you can see by default, because we didn't actually do any pre-setups earlier, so that's why all the string fields like author, you have a text plus a subfield keyword. So ignore 256 is talking about if the content of this author is more than 256 characters, simply ignore the value, all right? The reason is because if this was actually a free text field, like some 2,000 characters, so there's no point to keep a 2,000 character long keyword. because honestly, nobody will remember all those 2,000 characters in the exact way. All right. So there must be some typos. There must be something missing. So that's why there's no point to do so. It's meaningless. And so that's why we say that the maximum upper bound is only 256 characters. All right. If not, if you're bigger than that, we simply ignore it. All right. Ignore and do not provide a value for this keyword. Okay. So you can see most of the strings, they are text and keyword, text and keyword, text and keyword, text and keyword. That's it to the end of time. So does it really make sense to have a keyword for some fields like content? All right. I mean, for categories, okay. But for content, it doesn't make sense. For example, when I do a search, right, you can see that the content is kind of like super long. All right. It won't be 256 characters in this case, but it's still very long. So now let's do a matching. All right. Should be content. Now, if I use content of keyword and then I exactly paste the same content here, I actually got null. All right. I actually got nothing. So that's interesting. However, if I use a keyword field, I get exactly some content. Actually, 1,000 contents. All right. Let me just try again. I'm just wondering why it doesn't work here. So there must be some characters missing, I think. Actually return nothing. Because it's more than 256, I think. Let me just do a count, okay? How do you do a word count? Word count. Word count character tool. Let me see. It's 311 characters. So that explains why I cannot find the content, even though I'm giving you the full content here as well, because it's more than 256 characters. So we simply ignore this field. All right. So let me see if I have something smaller than this one. You see, all the contents are so huge, right? So it's quite difficult to find something that's less than 256, I suppose. So let's try to find something like this. I remember there's something like release something. Release. Still very long. So maybe this one. Let's try. This one sounds a little bit smaller. Still 300 something. Maybe I couldn't find the better one. I need a very, 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 very small one. Okay, so maybe this way. We change the field. We use the SEO title instead. All right. We use this one instead. So that might make sense. SEO title. Okay. And now if we want to make sure that the keyword will work, we need exact matching. All right. So that's why I copy the whole message here. And then I should get back exactly one document matching because it matches exactly this one. Now remember, keyword is talking about apple to apple match. So if I add a space in front of it, you get back nothing. All right. If you change the upper lowercase of it, you get back nothing. All right. So it must be exactly the same. Then you get back something. Now, so this also explains why it doesn't work for some fields like content, because the first thing is content is very huge. It's a very huge pile of text. Who is going to remember every single word without even a typo or maybe upper lowercase, that kind of differences? So that's why it doesn't make sense. And so the optimization for content field should be only a text, no more keyword. All right. Now, next thing, can we actually do a aggregation or sorting based on a normal text field? Now, just take example. I just do a sort on a field called content and see what happens. It would just give me exceptions and say, hey, it doesn't make sense, right? We'll explain why it doesn't make sense later on, but I just let you know you cannot sort or aggregate based on a content field. All right. But on the other hand, if you use content of keyword, you can actually sort it. All right. And also the sorting values here will be something like this. Welcome to blah, 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 blah. So exactly this is the content here. All right. Now you might ask one more question. It's like just now I say that some contents that's over 256 characters are ignored, right? Because they simply do not have a keyword field. So when I do a sorting, what will happen? So all these documents that doesn't really have a value or maybe a null value, they are pushed to the end of the ordering list, because simply when you do orderings, right, it now also has a position. All right. So for example, if I do something like ASC, you should actually get back the contents of empty strings and some other things as well. So I think there should be something else rather than this. So maybe size of 100. Keep on going up fill. Yeah. So I think all the null values are actually pushed to the very end. All right. So if I exactly have the 2000, I suppose the longest one should be at the very end. It takes a long time. Yeah, the longest ones will be at the very end. And what about descending order? Let's see. Yeah, it makes sense now. So because all the contents that's more than 256 characters, they're actually kind of like pushed at the very end of the list. So that's why no matter you're using ascending order or descending order, they are always at the very end. See, the very end are always the longest one because they simply have a null value, and we push them to the end of the ordering list. So that's the behavior, all right? And that is also a reason why having something like a very long content or keyword actually doesn't make sense at all right? Because the sorting order will be kind of like a little bit confusing, and you never know when this particular text will be displayable. Because like what I told you, if there are more than 256 characters, they're handled as a null value. And null values are always at the end of the sorting list, no matter you're using ascending or descending order. All right. So that might kind of like create some confusions to what you're expecting as well, right? Okay, so despite of all these things, right, these basic facts, now the next thing is some APIs that you might be interested in. We've told you that there are a bunch of analyzers, right? So you can run something like post, analyze, and then you provide the analyzer name. So for example, by default, we're using something called standard. And then you can provide something for, it should be messages. Text, okay. And then you provide some strings that you want to analyze them. For example, I'm just get a smaller one, okay? Now take example, we've got a short message like this, all right? And when we run it, we will find that all the tokens after the breakage, after the analysis, will become something like this. So you can see welcome becomes the small welcome. We've got the next word to here. The dot is gone. And then we've got a word called this is a blah, 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 etc. So this is the idea about the analysis. We are using the analyzer to analyze this part of string. And the corresponding tokens will be here, all right? Now, let's change this to another analyzer called English. Now you'll see that there are some differences between standard and English. For example, the word welcome has become welcome without the E. And then to is gone, this is gone, is gone, a is gone, but weekly becomes weekly. All right, so you can see some of the words are gone, like to this is a. So these are what we call stop words. Now, stop words means that they're not meaningful to our search context. Simply, that means you will not be typing something like this is a inside your search bar. Now, rethink. If you're going to Amazon or going to some e-commerce website, will you type this is a something? Probably not a very high probability, right? So that's why sometimes when we analyze these words, we remove them simply. Okay, so that's is the behavior for English analyzers, all right? So what about some other language analyzers? So let's take a look on the Elastic's built-in language analyzers. Language analyzers. So as I remember, there's also Indonesian language provided. Yeah, we got Indonesian languages, right? But it's a little bit difficult to write, I would say, because we need to use something. So let's try. So let's try to use the Indonesian analyzer. And we use some Translate Google to help me because I don't know the language. Take example, uh, Elasticsearch is a good tool, right? And then I would translate to Indonesian language. Indonesian, where are you? Where are you? Where are you? I. Oh, yeah, here. Okay, so this is the word, right? So what we can do is we can change this to Indonesian, okay? And then I'll paste this text here, okay, and run it. You will find that actually within all these 6 words, right, only a few come back. For example, a lot, I don't know how to read, bagas or bagas, something like that. And the other words like young, adala, those kind of things are gone. So I assume that these words are just stop words. So let's just do a cross check. All right. So this word is. So that's why it's a stop word. So we throw it away. All right. And also for the other word like yang or yang, I don't know how to read it. You find that this is something like another stop word, which. All right. For example, a and der, is and ma, they are all useless words for most search use case. So we simply throw them away. All right. And for other words like a lot, so this is an important word. This is the word called tool. So make it simple. Tool is not something what we call a meaningless word. For example, a and there is not useful, but tool, it describes this sentence. So that's why we keep this token here. All right. So that explains why we will do this kind of operation. All right. So for Indonesian language, it means simply we will get back the useful, important tokens. For the others like is and ma, that kind of days, throw them all away. All right. So that's the idea. So maybe it's useful to you because I don't know your use case. You might be analyzing the local language as well as English or some other languages like Japanese and so on. All right. So make good use of these things because they already have the capability to do so. All right. Okay. Summary. I think we can kind of like skip this. Not too important. Okay, so by default, full text search in Elastic are case sensitive? No. For full text search, we always lowercase them, so it's case insensitive instead. All right. Now, number 2, how many times will a dynamically mapped string field be indexed? 2 times. Text plus keyword field, so index 2 times. Number 3, certain aggregations can only be performed against a keyword. So this is false, right? The reason is all aggregations must be performed against a keyword field. So it's not certain, it's actually all of them. All right, all of the aggregations must be done through keyword. All right, so that's why it's not true. All right, unless I don't know the wordings. All right, I would say it's totally wrong. All right, all aggregations must only be done through aggregations. Okay, so now let's take a short break. Let's take like 10 minutes. Okay, so we come back around, okay, maybe 10:25. Okay, so for me it's 6:25. We come back this time and then we'll continue lesson 3, inverting index and document values. Okay, so if you got any questions, jot it down here, I'll give you some answers. Okay, continue the lesson. So now we're going to lesson 3, the data structures, inverted index and doc values. Okay, so before we talk about which data type will create which kind of data structure, let's start with something called inverted index. Okay, now inverted index is something like this. So if you ever read a book, right, a normal book, at the very end or maybe at the very beginning, there should be a section called glossary. All right, or maybe it's also called index. Depends on which where this book is written. So usually inside the glossary or index section, there is a bunch of keywords, and these keywords are sorted. Okay, so the first thing is there are keywords. The next thing is they're sorted alphabetically, and also on their corresponding right-hand side, there should be the page numbers or where this particular word can be found. So this is a glossary or index section. Now, why do we need this section then? So the truth is, if you ever read a book, a physical one, not PDF, that kind of thing, when you're looking for a particular word, in the old days, the fastest way is to go to the glossary section and look for that particular word. Take example, I'm looking for a word called search, okay? If I look for a word called search, then I'll go to the glossary section and take a look on that list. If there is a word called search, and it tells me that it's on page 2 and page 12, so what I need to do is just go to page 2 and look for the corresponding word and the corresponding paragraph. Does it work for me? And also go to page 12 and look for the same word, look and read for the paragraph, and to get back the information I need. So that's the fastest way to read through a book, all right? Instead of like page by page reading it and find that, oh, so this is related to search, this is not, blah, 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 all right? So that's why we have a glossary page. So for Elasticsearch, it's the same thing. If you do not create something like an index section, then every time when we try to do a search, right, we actually needs to go through that millions and billions of documents, look for that field. Do you have a word called search? So that will be super slow, all right? On the other hand, if we already have this section here, okay, we just look into this little section and search for a word called search. So if there is a corresponding set of document IDs, then we know these documents must contain the word called search. So that's why it makes your search experience much, much faster. All right. So it's just like reading a small lookup table and finding the corresponding results instead of like every single document go to search for that particular keyword. All right. So based on this concept, we create something called the inverted index data structure. So you can see on the right-hand side, this is kind of like the idea about what an inverted index it is. To be honest, it's a little bit like lookup table. So you have the terms here, you have the corresponding document IDs as well. Also, these words are sorted in alphabetical order. So that's why kingdom is at the top, states afterwards, and united following. All right. So that's why now if I give you 3 documents for a particular value, for example, country name, you'll find that all these values are broken into tokens and then sorted inside this lookup table and with their corresponding .IDs. So the next time when you want to do a search, right? For example, somebody type in states. So states, you will see that they are available inside document 1, 2, and 3. Oh, sorry, states is only available in document 1 and 2. So that's why doc 1 and doc 2 will be returned as a hit listing. All right. So that's exactly how we do a search in general. So you can guess, even though we have like billions and millions of documents, all of these contents are broken into little pieces like tokens here. And we just need to go through this token list and take a look where you can find these documents. So that's why it's very fast instead of like going through those billions of documents one by one. All right. And also that explains why some analyzers, they remove stop words. Now remember, we're talking about all the documents inside the index. The contents break them into this index list. So that's why the less contents in this list, the faster will be the efficiency for searching a match. So that's the reason why for some analyzers, we remove stop words like AM, there is, and MOB. Because the first thing is they are not really useful. The second thing is if they increment the size of the final inverted index, you will make that search slower. All right. So that's the idea about inverted index. Now, however, inverted index is not 100% useful to all use cases. Take example. If we do a sorting based on the text field using the inverted index, it doesn't work. Okay, the reason is because logically it just doesn't work. For example, I've got one sentence like this, all right? Okay. Elastic is a two. For example, just this simple sentence. Now, based on what we know, we break it into pieces, right? So now elastic is one word, is one word, A is one word, blah, 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 etc. And we sort them in the alphabetical way. So this text will now become A, and then elastic. Good is 2. So after doing the lowercase and breakage and resorting it, that whole string becomes a elastic good is 2. Now, this is the question. If I want to do a sorting based on this data structure, a elastic good is 2, how can I sort it? So the first thing is you need a way to rebuild the original string. You need to rebuild it back into elastic is a good 2. Then you can start to do a sorting. But based on the data structure we have, impossible. So that's the reason why for text fields, they are good for doing something like full text search, but they are not good for doing sorting or aggregations in which we need the original string. All right. So that's why when you run this kind of sorting with a text field, you get exception. The exception will say that the text fields are not optimized for this kind of operation because we need to rebuild the original values and it's nearly impossible. So the next thing in the bold colors is please use a keyword field instead. All right. The reason is because keyword fields have the original values without any processings. So we use that value to do sorting, aggregation, and so on. All right. So that is the reason why. All right. So text fields cannot be useful for sorting, aggregations, and so on. So that's pretty much the idea about the inverted index. And remember, text fields, they always create inverted index, right? Now, another data structure is related to keywords. So keywords will have a data structure, actually, so actually keywords will have an additional data structure called dot values. Okay, remember, it's an additional thing. So keywords also have the inverted index, but their inverted index will always be the original phrase. So we do not do tokenizing. We simply, what you give me, what will be the final result in the inverted index, right? So this is also important because we also need to handle apple-to-apple match. So that's the reason why we will also create an inverted index with the original value, right? The next thing is we also create one more thing called dot values, which is also having the original values of that particular string. So you can see exactly what you give me will be exactly the values here. Now you might ask us like, why do we have this kind of data structure? The idea is because in the old days when we're talking about like databases, right? We need to traverse through the record set, okay? And then each record set contains a mixture of columns, right? So we need to go to each column to see if it is actually related to country name. So we're doing two loopings. So the first loop is the record. Second loop is inside the record, the columns available. And then we look for the column called country name. And then we try to do a match. So actually too many loops. So on the other hand, document values is what we called a, I didn't tell you what's that. I didn't really tell you. So this is what we call a columnar store, right? So columnar store. So doc value is a columnar store, which means that if you're looking for a field called country name, we directly go to the column called country names. And then we go to loop only once directly and see if there's anything called United States. So that's why it's faster. So you might start to think, it sounds a bit stupid because why are we creating additional data structures? Why don't we just loop over? The reason is, again, because this is a big data software. We're not talking about some thousands of records. We're talking about some millions and billions of records. So there's no point to loop through all those billions of records and then do the second loop to find the column. Instead, we directly create each of the column itself a data structure. So if you know you're going to look for something inside that particular column, directly use that column's data structure and do a matching, all right? So that will free us a lot of non-necessary loops. So that's the reason why we still create a document values, even though it sounds a little bit stupid, all right? And again, this is not something that we created. In many big data software, they are also using columnar stores as well. Okay, so back to the story. So if text fields cannot do sorting, then which field can? So in general, keywords can, because keywords contains the dot values as well as the original string values. So we can always use that as a sorting criteria. So now you get back what you want. Now, a little bit interesting thing about the optimization of mappings is some parameters you can apply, but again, not necessary, okay? Now, the first thing is, if you think that a particular string, you just need them to, you don't need them to be searchable. You can actually set index to false. So now the inverted index will not be available. On the other hand, you can also disable the document values, which means you do not want them to be searchable. I mean, you don't want them to be sortable. You don't want them to be aggregatable. Then you can set dot values to false. So final piece is you can disable the whole field. That is no search, no aggregations by setting enable to false. So the final piece, disabling at the whole object. So sometimes you will see that there are some sub-levels, right? For example, user dot first name, user dot last name, etc. If you want the whole user, the whole mother group to be disabled, you can just go to that root level and disable everything. All right, so that's another possibility. So that's pretty much what you need to know for this lesson about the data structures. Okay, some quiz, right? You should sort by text field instead of keyword field. No, you can try. It will just throw you exception. So you should sort based on keyword field. Now, true or false? If you set the index to false of a field during the mappings, we assume, you can no longer query on that field. This is true because you're not creating inverted index. So remember, when we search, we're looking for the inverted index. So if you didn't create it, of course, not searchable, all right? Finally, when you enable set to false for a particular field, this field will no longer be inside the source. Now, this is a concept. Now, the source is the original value that you pump in on day one. It will always be there. We will not remove it, all right? But on the other hand, when you pump in the data, we will create data structures when necessary. If you set enable to false, that means all data structures are not there. So that's why this field is not searchable, not aggregatable, etc. But the source still contains this value, okay? So that's the concept. So everything you give me at the very beginning is still here. But the corresponding things, for example, the data structure capabilities, if they're not there, of course, they're not here. All right. So let's take a break, like 15 minutes. Then we'll go to the last lesson for this module. All right. So 15 minutes. So that should be 55. Okay. So let's compare like exactly XX00. So have more time to do labs or rest or take a break or have breakfast, etc. All right. Okay, let's continue. So now we're going to custom mappings. Okay. All right. So to be honest, this is not really talking about custom mappings, but kind of like talking about parameters to change the behavior a little bit. All right. Okay. So take example, you got a field like, for example, like the string fields, right? We've told you that some of the parameters is you can set the index or set the dot values to true or false to kind of like change the behavior of what kind of search functionality you can provide for this string, right? So that's only one of them. So in this lesson here, we're talking about a few other usual settings for the for the corresponding fields. Take example, we've got a date field. So for date fields, one of the things that you probably need to set is the date format. So is it the DDMMYY or maybe something what we call the strict date optional time? All right, so there is a bunch of built-in datetime structures as well. I mean the formats. So you can take a look at this link here. So the green link here. So it will have some some built-in preset date formats that we can use. But if you actually have some strange formats that is using in your company, etc., you can actually provide them through the format as well, like dd/mm/yyyy. All right. So there's also a double OR here. So this OR is talking about you can use this format or the other format. So the other format here is talking about epoch in milliseconds. All right. So the interesting thing is, right, when you provide something like a comment time, maybe this comment time is not controllable by you because it's coming from third-party libraries or whatever. So there might be a chance that it can be in the first format or the second format. So that's why we kind of like set this format value here so that we can accept this one or that one. All right. But for the other unknown formats of the datetime, we'll simply throw exception because we do not know what they are. All right. So be very careful about this thing. So copy two. To be honest, copy two is talking about like if you have multiple string fields that is correlated to something, for example, the address, right? The region, country, city, you might want them to be kind of like mashed up into one final field when you do a search. So this is the idea about using copy two. So you can see the configuration is quite simple. You create a field called region name, city name, and country in the same way, but you add one thing called copy to. So all the values for this field will be copied to another field called locations combined. And locations combined should be a text field because we're going to do a token level match on that. So instead of like using a keyword, all right? So it doesn't make sense to have a keyword for to combine the field. And so once we combine all these things together, when we do a search, we can directly use the combine the field to search these things, all right? And now no matter it is the city name contains Victoria or the country name is Victoria or the region name is Victoria, you can still find it out because now you have a combined the field with all those three fields values. And if they contains the word called Victoria, just bring it out. All right, so that will be super useful, especially when you're doing something like e-commerce, in which, you know, when you fill up that e-commerce form, that kind of thing, typically I would just kind of like copy and paste the same address to all the three address lines. All right, and so that is when this kind of search will be useful because, come on, you might get a street number on the first address one line or address two line, but anyway, as long as they're here, somewhere inside these fields, they are searchable. All right, so that would be good. Null values. Now, null values is talking about exactly the first example. You got a field called rating, like this. All right, so this is what we call null value. Now, remember, if your document doesn't contain a rating field, the rating field for that document is not null. Okay, remember, you need to explicitly have a null word here. Then we treat it as a null value. If not, it is not a null. Okay, So don't kind of like confuse about this thing, because it's totally two different meanings. So let's say if we have two documents, one has a rating null, one has a rating 5. When we do the average, you'll find that the value is 5 here. The reason is because the one with a null value for rating is excluded. All right. So similar to the example I was talking about just now, like sorting, you will still remember, if you have a null value for the content field, etc., you actually will push all these null value things to the very end of the list. All right. So that's the idea about null. So we usually exclude all these things when necessary. So that's why when you do the average based on these two documents, you only got number 5. Simply, right? Now, the interesting is if you think that, yes, a null value should be defaulted to something else rather than null, like for example 1.0 here, you can actually set a null value operator for the mappings. So that means if you have an explicit null for rating, it will be treated as 1.0 during the calculations. So that's why this time when you run the average again, you get number 3. All right, so that's the point. So 1 plus 5 divided by 2. So now you got number 3 instead. Coercing your data. Now, by default, if you didn't set anything, we will do coercing. So coerce is data cast. So which means if you give me some values, we try to cast them into the correct data type. So here we assume that rating is a long integer. So if you give me a 4, that's good. If you give me a 3 with quota string, we try to convert this quota string into a number, and so it becomes 3. Now 4.5 is also a valid casting because we will just cast it back to number 4. So that's why we got 11 when we do a summation, all right? So there are cases that sometimes we might want to disable this coercing effect by setting coerce to false. All right, so if that's the case, the first one will work because you give me exactly number 4. Second one will fail because even though it's logically number 3, but we find that the data type is a string, so it's already invalid data type, so we throw exception. 4.5 is also invalid because the data type is a floating point instead of a long integer. All right, so this is the effect. So if you were a developer, when we talk about coerce to false, we are doing a 3 equals check. A equals to 3. We're not talking just the logical value, but also the data type. So when we set coerce to false to true, we're talking about A equals to A. So we're just talking about the logical value, but we're excluding the data type. All right, so that's why be very careful about this as well. So the suggestion is in production environment, unless you know, unless you actually can control the data quality, you should not touch coerce. So just let it to be true by default. So just let it try to do data casting, all right? Now define your own mappings. So we've been talking about defining mappings quite some times, right? It's the best way for production environment because we probably want to have the mappings kind of like declared before we push in the first document so that we don't have some unexpected data types to come out. But the problem is every time when we write a mapping, it's quite tedious because it's quite long, lengthy, right? So here we'll introduce you a very quick way to produce the mappings for a particular index, all right? So think about it this way. The first step is actually to create a dummy index, and then you provide the content of a sample data. So for example, sample document, and you push it in. Then you can run the get mappings generated by step 1, all right? And because we usually guess the mappings for you. And for most cases, the guess is quite okay, like what we said, right? But of course, you might want to fine tune a little bit. So that's why in step 3, you fine tune the corresponding fields mappings. For example, this string should only have a text, but not keyword, blah, blah, blah. Now, finally, create your final index with the modified version. And so that is how you make the mappings available because you're using the dummy to guess. 90% of the skeleton. And probably you're just changing 5 to 10% of the rest. And then copy and paste the whole thing into the targeted index. Now you should get the correct mapping set, the mappings set it for that particular index now. So in details, it will be something like this. You use a temporary index like blockstemp, you throw in a sample data, and we then run the get. All right, so get the dummy index and mapping. You should get back this set of guess the mappings. Now, step 3 is when we apply our changes. For example, category should be just a keyword, but content should only be a text. Well, date, you might want to provide your date format in a particular way, blah, blah, blah. Locales will be just a keyword, etc. So you change all these things, right? And once you apply the changes, copy and paste that whole modified mapping and put it into the final targeted index. For example, in this case, blocks. So now your blocks will have the correct mappings, all right? Not the guessed up ones. And then you can start to pump in your documents as usual. And this time, everything should be kind of like optimized, all right? Unless there are still some changes that you want to apply later on. All right, so that's why this is the fastest way. You don't need to field by field declare all those behaviors. Now, final piece of this lesson is talking about the dynamic templates. Okay, so setting up your mappings is one way, all right? So you know that you might need to start from the very scratch. That is, every single field you define the behavior, etc. That's one way. Second way, to use the dummy approach that we just gone through. The third way is to use something like a dynamic template. So dynamic templates help us to create the corresponding mappings based on rules. Okay, so we define the rules. Take example, the last big bullet point. If a particular data type occurs, use this set of mapping. So we declare the rules based on data type. Number 2, we can declare the rules based on the naming conventions as well. If it starts from I underscore, it should be integer. Next thing, the path of the field. Sometimes we're not talking about every single field should work like this way. Instead, when you're under this hierarchy, for example, client.address. So I just need that client.address to be mapped in a different way. So we're talking about the path of the field. So kind of like the hierarchy. So based on these 3 rules, we can apply those auto settings for us. Now take example. We're going to create a dynamic template based on the mapping type string. So any string that comes in, make it as a keyword only. So we do not need a text plus keyword, only keyword, all right? And so the example is when I create a brand new field, which is a string like thumbs ups, that kind of like emoji, that kind of thing, you'll find that it will become a keyword instead of text plus keyword, all right? So this is the third way. So instead of like declaring everything by default, or maybe using the dummy index approach, you can also set up the rules. So whenever Elasticsearch, whenever they see this kind of data type comes in and matches this rule, okay, we will apply the mapping for you automatically. All right, so that might be also another way to help you out. All right, much easier. So that's pretty much for this lesson here, all right? Now, remember, mapping parameters is actually just another way to change the behavior of a particular field in general. Now, the first thing that we've learned in the previous lesson is talk about controlling what data structures we can have, like index to true, enable to true, and also, of course, dot values to true, etc. We also learn in this lesson here some of the others, like for example, for date fields, we can actually set the format instead of using the default strict optional time format. And for some others, like when we're talking about something like multiple correlated fields, like the address parts, right? Like city, region, country, address line, or building, that kind of thing, we can actually merge them together by using a copy to. So all these are some of the parameters that we can play with during the mappings region. All right. And another thing is the second part pretty much is talking about how do we set up a index with correct mappings. So again, three ways at least. So the first way is you do it by yourself, scratch. So every field you declare those behaviors. Second way is you can use a dummy index approach and then you merge your changes. Okay. And third way is by using dynamic templates. And dynamic templates is talking about rule setting. So rules can be set up based on data type, based on the naming conventions, as well as the hierarchy or path of that particular field. So the mapping parameter that we need to change the field state format is exactly something called format. Okay. Now, true and false, true or false. Using copy2, you can add a new field to the source. This is another concept. So for copy2, we actually create the data structures at the back, but we do not pollute your original source. So your source will not have a field that is created through copy2. All right. So you won't have something called locations combined. Instead, you will just have the normal fields like city, region, country. All right. Remember, this copy2 is a background data structure. So it doesn't pollute your source at all. So you won't be able to find that thing there. Number three, use dynamically generated mappings to help create your custom mappings is a common practice. I would say yes, but again, case by case, because if your data set is very simple, it's always like less than 20 fields. So maybe using dynamic templates might not be something super useful to you. But for other users in which they have a lot of fields inside the documents, using dynamic templates will be a common practice because they don't need to, per field level, to declare the rules. Just make sure that if they are strings, make as a keyword. That's it. Super simple, right? Good. So now we've gone through all the module 4 and the rest. So let's see. So today we actually will also need to cover a little bit about the module 5. So again, so let's take a short break and then we'll come back again. Let's see. So roughly 15 minutes. So now it's 20, 15, 35. So around 6:35, then we will come back for module 5, where we talk about the relationships between shots, notes, and of course index as well. All right. So let's come back around 15 minutes. Okay, so let's continue. So now we go into module 5. We'll talk about the NOx, SHOTs, and index. Okay, so we got like 4 lessons again here. So we talk about master nodes, where we talk about different kinds of roles for each of the nodes. We'll be also talking about understanding how SHOTs work in general and the distributed operations, which is when we ingest a data, how will we actually handle it in the SHOTs level? And when we search, how do the SHOTs help us to make the search possible, etc. So let's start with master nodes, the easiest one to understand. Now, creating an Elasticsearch cluster, right? There are some questions, right? How can we add more nodes to our cluster? And also, how do the nodes communicate? So in general, the simple answer is when we say expand the cluster, just add nodes, all right? But what's the mechanism behind? So there must be some handshaking things, right? So that's why we're going to take a look at how these things work. So internally, actually not just internally. So for Elasticsearch, we have 2 communication channels. One of them is called the HTTP, which is for the outside world. Okay, so for example, if you have written a mobile phone app or maybe some just normal web apps, and you want to talk with the Elasticsearch cluster, we'll be using a HTTP channel. Okay. On the other hand, for internal communications, for example, Node 1, Node 2, Node 3, they need to exchange data. So this is done through something called transport protocol. Now, basically, HTTP is for the external world. So you can guess is like what we've talked about in day 1 when we talk about the goals of Elastic. So one of the goals is to make sure that we can integrate with any kinds of programming languages in the market. The reason is because we're using a REST API layer. And so this REST API layer requires an HTTP connection, as well as the capability to handle JSON data structures. So that's why for the external world, we actually will set up the REST API in between. And then they will use the HTTP protocol to communicate with us. And by default, the HTTP module is set to localhost as the host IP to listen to, and then also a port number ranging from 9200 to 9299. So if you didn't set any port number, the default one will be 9200 exactly, all right? And the next one on the same IP address will be taking 9201, etc. So if you want to change these kind of configurations, you can set the http.host or http.port to something else rather than the default values. Now, internally, we need to communicate. Now, take example, Node 1 might have some changes in some configurations. It might need to inform Node 2 and Node 3 at the same time. So we'll be establishing another kind of communication known as transport. So transport will also bind the local host by default. And the port number this time will be 9300 to 9399. So again, if you didn't do any configurations, we will pick up 9300 as the default port number. So with this, within the same IP address, the next node that starts up will pick up 9301. All right. So that is the common practice. Now, again, if you want to change either the host to be listened or the corresponding port, just go to the YAML file and change transport.host and transport.port to the corresponding value. So this page is talking about some additional network settings that you can play with. So we've already talked about the host and the port number here, right? So when we talk about the host, we can also separate them into bind versus the publish host as well. So for normal situation, publish and bind host should be the same host IP, all right? Unless you have multiple network cards. And so you want to listen to different addresses, right? Then you can set the bind host to something else rather than the initial ones, all right? So publish is the same thing, right? So on the other hand, on the upper terms, right? Usually because each of the machines that we have for deployments is only having one network card. So setting network, setting something called network.xxx will be good enough. because network.x66 means applying to both HTTP and the transport protocol corresponding setups. So take example, network.host set to localhost means that the transport and HTTP host are also pointing to localhost in the same case, right? But if you do have multiple network cards, you can actually change the HTTP protocol to point to address 1, transport protocol point to address 2, etc. All right. So that's why there are this kind of high-level settings, right, or low-level settings, depends on your situation. But for most cases, we only got one network card, so we'll be just using network and using host. That's it. All right. There are some other additional addresses that you can set if you want. So underscore local underscore is the local loopback address, which is 127.0.1, or exactly something called localhost. Usually, we will be using the second one called site. Site means that it will sniff out the corresponding network IP address for us automatically. So this is super useful when you're using something like virtual machines. Like, for example, you're using Docker to do deployments. So every Docker instance or container that's running, there must be an internal IP address, right? So this IP address can be sniffed through using site, all right? So remember, this makes sense because if you're running a container, unless you SSH into this container, then you will know the IP address. So that doesn't make sense because when we deploy those containers, they are always dynamic. So who knows what is the IP address? So even though afterwards I know the IP address, how should I kind of like update the deployment? So that's why we usually for this situation will set site underscore site. So let Elasticsearch sniff out the IP address. So global is, on the other hand, something that globally understood. Now take example, the 8.8.8.8.8 is actually the DNS for Google. All right, so that's why if you have this kind of address for your company, even though it's nearly impossible, I guess, you will actually be able to set this IP address as a global one. All right. Now, finally, if you have multiple network cards like Ethernet 1, Ethernet 2, that kind of thing, you can actually set the network interface here. For example, underscore EN0, that is the first Ethernet address instead of hard coding something, all right? So that's why in the gray box here, a common setting is usually network.host set to site because we never know what is the actual address that was under this Docker container, for example, all right? Some other settings, examples could be like setting HTTP publish host to global address, or maybe transport bind host to just a non-local host, etc. Right? But usually the first one is the most important one, network.host using site. Discovery module. Now, after understanding the protocols to communicate as well as some special IP addresses that you can set, now let's take a look. If we if we started the nodes correctly without any issues, then how can they join together? So in one of the lessons in the very beginning, we told you that every cluster has a cluster name, right? So that's just part one. So at least they know where they should be grouped, all right? So this node and this node should be under the same cluster group, and that node should be from another cluster group, all right? So just like humans, we know that we are working for my company, all right? You're working for example, somebody's working for a bank, somebody's working for a software company, etc. They won't go to the wrong company, all right? So that's just the step one. Now, step two, once they know that they should be working in that particular cluster group, how can they join? So it's just like you're a brand new employee. You need the access card to open the doors of your office. So you need to get that card first. So how do we get that card? So basically, we have something called discovery module. Discovery modules by default, if we're not using any special deployments, we'll be using SAN2. So this SAN2 discovery module works in this way. Now, if somebody starts up like Node 3, it will try to look for the seed list address. So this is our responsibility. We need to set the seed host address, right? so that we know if we join, we need to find that particular node to make a handshake. All right. So just like normal humans, when we join a new company, we need to know who's the HR so that we at least get the so-called joining package or whatever. We at least have the access card to the office. So we need to know who to find at the very beginning. So that's why we need to have this seed host. And so usually seed host contains one or two addresses. So we'll be looping through them. So the first time, loop for the first one, then the next one, etc. So then after getting this IP address, we try to ping them. So you can see, is the host reachable? If it's true, good. That's good. So we can kind of like handshake and join. However, if it's not no, we'll need to look for the next one and keep on pinging, all right? So the worst case is if all of them are not available, we will start up its own cluster. So usually this is not a very good idea because it might be isolated from the others, all right? If the ping is forbidden, is it possible to join a cluster? So we're not really using the ping. So we're using something like some transport protocol, that kind of thing to communicate. So it's not really a normal ping. I mean, even though I'm using that word, all right? And the next thing, next questions maybe is like if, take an example, if we never able to find those addresses, right? Is it possible to join a cluster, right? So the answer is no, you can't join it. And you can see the final step, right? If we have more hosts to try, no, it will start its own cluster, which means it's an isolated cluster, okay? So you have node 3 with that cluster name, but you only have yourself. You cannot see the others, all right? So that's the worst scenario. So that is the behavior by default, okay? So usually if you find that, if you know this cluster contains at least a few machines, but after you join, you find that you cannot see this machine anyway, or maybe you can only see yourself, but not the other machines, you should actually check whether you're really joining the normal targeted cluster. If not, something's probably wrong with either the network level, because maybe your network has a subnet and your subnet cannot access the other subnet, so you cannot join. That might be one reason. The second reason is because the configurations got problem, so you always cannot ping the machines. Or maybe another thing is the firewalls that actually block you from accessing those machines. So that will also cause you something like an isolated cluster. Okay. So all these things you need to kind of like, well, I think you don't need to have a same subnet, but you need to make sure the firewalls, they let you pass through, right? Because some firewalls is like, they have a subnet for this department, another subnet for another department, and they totally block them from pinging each other. So if that's the case, you would need to at least find a way to have a drill that you can drill through, right? If not, you will not be able to join that cluster. Yeah. So it doesn't need to be the same subnet, but you need to have the firewall rules to let you access the other subnet, all right? Yeah, so it's kind of like networking problems. So this will happen if you're having something like a multiple data centers, maybe, in which the networks are totally different. The IP address might be also totally different, and you need to make sure the firewall have rules that lets you pass through. If not, it will not be able to join. Yeah. So then the seed host, right? So we're talking about the original set of IPs that we need to know if this network or this cluster is actually online or not, right? So basically, there are two ways to set these things, right? The static way is go to the YAML file, then you set discovery.seed host and get the host names, right? So that's the static way. The other way is through a file. So this file is by default under the config folder, and then there's a file called unicast host.txt. Okay, so what's the difference between the two? So one of them is a dynamic one, which means that you do not need to restart the node to make changes on the discovery seed list. Okay, because you can always go to change that text file, right? Instead of the original set, right? Number two, plugins. So this one is talking about like if you're actually deploying not on normal normal situations. For example, something like what we call the self-maintained environment. That is, you have the hardware inside your data centers, that kind of thing, the traditional way. Instead, if you're actually running the deployment on cloud environments like Google Cloud, Amazon, or maybe something like Azure, that kind of thing, you will actually need to install additional discovery plugins because the Amazon way to talk with each other, the machines, they're different. So we need a plugin to make sure that you can talk. All right. And the same thing, if you're using Google, you need the GCE version because again, GCE will be different from Amazon. All right. So that makes sense. All right. If you're actually using Kubernetes, you will actually also need to use the Kubernetes plugins to discover the machines and how they talk with the pods, etc. All right. So all these things actually make sense, but you just need to install the plugins and things should work. And one more thing, because you're installing plugins now, you will need to do a restart of your nodes as well. All right, because if you install a plugin, they don't realize that this plugin is available until you restart the node. So usually we will need to do a full cluster restart for this situation as well. All right. The second half of this lesson is talking about some cluster state things. All right. Now, the first important thing is inside this Elasticsearch cluster, there must be some important information to keep it running. For example, who is the master node? Where is the, where are the data shards located? Is it on node 1 or node 2 or blah, blah, blah? And also, how many nodes do we have inside this cluster? For example, if node 3 joined, then probably our list will have node 1, node 2, and node 3. We need to update this information, right? And if node 2 actually offline, all right, we need to also update this information so that the cluster, we know how many nodes are still running, all right? So all these kind of things, we need a way to store it. And we store it in the way called cluster state. So cluster state is just a very big JSON, key values, and it contains all the essential information about this cluster. So you can see here, we've got like cluster name, we've got the master nodes UUID. We also have how many nodes involved. We also have some metadata about this cluster, if any. We also got some routing nodes and routing tables. So routing nodes and tables is just talking about where the shards are. Okay, so remember, you pump in data, you're actually pumping into data shards. So where are the data shards? Are they located in this machine or that machine? Also, this data shard represents which data index. So this is the routing table and routing nodes. Okay, so they denote all this information there so they can do a tracking or what we said backtracking. We also have some information about the kinds of snapshots and the restore locations, etc. as well. So snapshots are backups. So we also need to know where they are stored in some ways, right? So after understanding this essential data structure, now the next question is, so we have this data structure, right, with all the important information. Where are they located? So by default, they are stored on every single node, all right? For example, node 1, node 2, and node 3. And however, even though we store all these informations in all of the data nodes inside the cluster, there is only one node that can update the data. So this node is called the elected master. Elected master node, okay? So for this elected master, right, you might start to ask, so how many elected master do we have? So the answer is there's only one and only one elected master. Okay. However, we do have a few backup candidates. So in a normal situation, when we talk about a production-ready cluster, we should have at least 3 nodes. All right. And these 3 nodes should also have master node capability. So that, yes, there is only one elected master, but, oh, sorry. And there's one elected master, but at the same time, we also have 2 backups. So if the elected master is offline, we still have 2 backups to compete for the next possible elected master. So that will be the situation, right? So remember, there's only one and only one elector master. And then why do we need to stress this one and only one master then? The reason is because this elector master, they are the one, he or she is actually the only one that can change and update the cluster state information. Now take example, now node 5 join. So this information will be available, right? But this information would only be updated by the elector master, all right? So that's why this is a little bit interesting. All right. So when we talk about these so-called changes, right, it is including something what we call creating the data, updating the data, deleting the data. All right. For example, deleting data indices or making changes to mappings or settings, or maybe something like adding, removing nodes or locating shots to different nodes. So all these we need to do updates, right? But only the elected one can update them. And afterwards, when we finish updating all these things, we will emit all these changes back to the other nodes. So that means now if node one is the elected master, all the changes will need to go through node one first. Then all the sub changes that has been made by node one will spread back to node two and node three. So they get the full set of updated information eventually. So the master eligible nodes, right? So the first thing is you might ask is like which other nodes actually can do the election then. So for the nodes that can do elections, they will need to have node.master set to true. So inside the Elasticsearch YAML file, all right, you will need the node.master set to true, like this. Then this node can actually be a potential elector master. Okay. Okay, so that's the idea here. So we need to have this kind of thing here. Okay, and the interesting thing is now all the master eligible nodes can vote. All right, so they can vote, right? And the master's election is like this, right? Because the case is we need to have something called a quorum. So quorum means that we have exactly half of the master eligible nodes available plus one, so that we can start to do the second level of election when necessary. So that's why we say in the production environment, we need to have at least 3 nodes. So half of them plus one means exactly 2. Okay, so that means now we've got like 2 nodes available to form a quorum at least. All right. So this is important because if not, we'll go into something called split brain scenario. Okay, so split brain simply means that you have your cluster separated into 2 because of something, like for example, maybe based on something like the breakage of the network or whatever. So you just split into 2 sets, and one set they have some nodes there, like for example node 1, and then the other set you have node 2 and node 3. Now the problem is if you only got node 1, right? This node 1 is the only one inside that half of the network. And based on the quorum concept, we need to have at least 2 candidates available. Then we can have a so-called master. So by default, this node 1 will now drop down back into a normal potential master only because I don't have the quorum. So this side is not a normal complete cluster. On the other hand, the remaining half, having node 2 and node 3, they have exactly minimum 2 candidates. So one of them can become the elected master. So maybe node 3 becomes the new master. All right. So that means now we kind of like handle the split brain scenario. If not, you can guess it's like if we have 2 separate segments, right? This side will say I'm the master, and this side somebody will also say he's the master. And after rejoining, now those 2 masters will have to fight to the death until the other one, somebody will become the so-called final master. So this is not a good idea because we want to make sure that if you have splitted networks, only one side should have a master. The other side will be incomplete, so they will be pending for instructions. They will not do any changes on everything. So it's kind of a read-only cluster. So when they rejoin again, so because this side is the new master, it's okay. So we'll just obey this new master and kind of like join again. All right. So that is what we call split brain scenario. All right. So in general, we want to make sure that this happens. And the good news is if you're using the latest version of Elastic, like version 7, all these split brain things are handled automatically. You don't even need to set some like minimal master node this setting. So that's why in here, we do not add back this minimal master node setting anymore, because the latest version, we handle it for you. You don't even need to know what is a quorum, what is a split brain, because it should not happen. All right. But anyway, since they mentioned this word, I'll need to explain this. So reasons why we need to have at least 3 master eligible nodes. The reason is because actually high availability. Like what I said, if the so-called master is gone, we still have at least 2 candidates to vote and become the new one. All right. So that's important. So you have a backup. So like a normal human world, you have your team, you have your manager, for example. But again, if your manager is away, maybe vacation or something, there is somebody to pick up his role. For example, assistant manager or acting manager, right? So that's the point. We also need a standby for the cluster. If not, your node one is gone, then the whole cluster is down. So that doesn't make sense. The voting configuration, if you're using the latest version like version 7, we actually would do the quorums and also the minimum master nodes, that kind of setting for you automatically, right? The reason is because, or actually the so-called magic behind is actually because we also vote or pick up the ones that can become the voters. All right, and this information is available through the cluster state by running this command. You can see that we have a cluster coordination and last committed config with exactly, in this case, 3 master eligible nodes that can join a election. So that means now we don't need to care too much, because we will automatically pick the correct number of candidates and then to do this kind of operation. Which what if we're using Logstash and 3 Elasticsearch nodes, which Elasticsearch IP used by Logstash? Good question. I should ask you which IP, because you are the one who's setting up the IP address. It's not me, so that's why I don't know. So remember, Logstash is just a normal application. If you want to pump data into Elasticsearch, you need to set up the IP address yourself. For example, node 123, which one do you want to push data to? If you want to push the node 2, you should have node 2's IP address set up in Logstash. All right, so it's up to you. It's not me. Okay, that's the thing. So can we have like a multiple addresses? Can we do load balancing? So let me just do a quick check. I don't think we can though. Elasticsearch output. Let me just take a quick look on the address. Is it an array or something? Oh, so maybe we can. Let me see. We have the host. Hoses. Uh-oh, it's not. Let me see. Okay, we can use something like this. Okay, so you can take a look on this link, right? If you want to provide multiple addresses for Logstash, you can actually do that. Okay. Master IP node or not? No, you should not use master node. So this is a very complicated question. So it depends on how big is your cluster. If you are just running a 3 node cluster, right? If you are having a 3 node cluster, so every node will be master node. So for this case, it's okay. So we just use any IP address you want. Any node is okay. But if you have something like slightly bigger, like maybe a 10 node cluster, okay, and then you tell me that you have some dedicated master nodes as well. For example, 3 dedicated. And the rest, like 7, are just data nodes. So in this case, you should not use the master IP, okay, the master nodes IP. Instead, you should use any of the data nodes. So you have 7 IP addresses because they come from data nodes. So you should use the data node address instead. All right, so that's the short answer. And I assume that you might not be using a very big cluster, so I guess you will be having like maybe all of the machines just a master eligible node. So the case is, if you know which one is the elect master, do not use that IP. The reason is because if you pump data into the master, elector master, if it crash because of too many workload, your cluster will be gone. So it's offline. So you should not ask the elector master to do additional things. All right. So instead, you can use others. Now, think about this way. It's just like a normal company. You have a CEO. Will you actually inform the CEO on everything about a company? For example, the toilet is very dirty. Are you going to tell CEO to do it? No. You will tell the corresponding people to do it. All right. So the same case for elector master node, you should not trouble it. Let it just do the cluster updates, cluster state updates. All right. So that's why no matter what, all right, do not ask the elector master to do any additional things like ingesting data. All right, because that is the CEO. You should not call CEO to do stupid things. All right. Instead, you ask somebody else, some other nodes to handle the ingestion. All right. So that will be the answer. All right. So try to think about this way. All right. Try to understand. Because if your elector master is offline, your cluster is gone. So that's why we should not use the elector master's IP no matter what. All right. Find other nodes to help you instead. Okay. Final word about a bootstrapping. Now, this is a step that we need to apply, but only for the first time. Now, take example, if you are going to set up a cluster, a free node cluster, for example, and for the very first time, you need to tell who are the nodes that is going to be the ones to participate in the initial election. So going back to the previous slide, we have this information here, right? We've got free nodes IDs. But then how do we know these are the free nodes for the very beginning? So that's why for the first time when you start up a N node cluster, you need to provide me the initial master nodes names so that we know, okay, so these are the free initial candidates that is going to do an election. And afterwards, when you start up the cluster correctly, these free nodes UUID will be here now. All right, so that is the point here. And so for the very first time, you will need to have this initial master node set up. But afterwards, when you start up your cluster correctly and keep on restarting, adding new nodes, etc., you do not need to have this set up anymore because we will be using the voting configuration in the previous page to conduct further elections if necessary. All right. Again, this is a bit confusing, I know, but this is how the send to discovery module is worked, how it works. All right. So this is a little bit, to be honest, to me, even though to me, I think it's kind of like weird. Why do we need to set up something like initial master nodes? If they were smart enough, they should be able to communicate through themselves and get somebody elected. But anyway, this is how they set up the mechanism. And for the meantime, just understood it. All right. Okay, so quiz, how does a new node join a cluster find the cluster? Okay, this is a very strange question. Joining a cluster, find a cluster. Now, the first thing is you need to have the cluster name set up correctly so that they know which company they should go to. That's the first thing. Second thing is we should have the seed host. That is the list of IP addresses that is used for pinging those targeted machines inside that cluster. All right. If that ping is okay, we have a handshake. Good. All right. Then we can join. If we can't, we will eventually maybe just creating an isolated cluster with only yourself there. All right. So what do you need to bootstrap a cluster? So for the very first time, if you're running an N node cluster, remember to set something like cluster.initial master nodes, telling this cluster, I mean, kind of like not telling, it's kind of like indicating that these three nodes will be the ones to compete in the master node election for the very first time. Finally, every Elasticsearch cluster should run an even number of nodes. This is not true anymore. So because now we do auto voter selection, so you don't need to care if you're running even number of nodes or odd number of nodes. It doesn't really make any difference. We will pick the correct number of candidates to form a quorum as well as to do election. So this is not true anymore. In the old days, this might be true, all right? But in the current version, like 7, we don't care. You just give me enough nodes to run and we will do everything for you automatically. So odd or even is okay. So that's why this is a false. Okay, for the current version, it's always false. Okay, so now let's take a break as usual, like 15 minutes. I guess today we might be able to have an earlier release, but anyway, so just let's see. All right. So we have a 15 minutes break. So 15 minutes now, 15, 17, 15, 20, 17. Okay, so let's come back around. It's 6:30. Okay. So around this time, we will continue to lesson 2, talking about different kinds of roles, the characteristics and responsibilities that a nook should have. All right. So just now we just talked about master nooks, right? Later on, we'll talk about some other roles as well. So stay tuned. Okay, last lesson for today. We'll talk about the NUC roles. All right, so it's pretty much a normal human, right? I usually use this example as like if you work for a startup company as a founder, so you are the only one in the company. You will be doing everything. You'll be a CEO, CFO, marketing, developer, database admin, blah blah blah. So even support. So you'll be everything. So that is you have a lot of roles, all right? But when we kind of like have a bigger company, we start to hire people. You will offload yourself. So you'll be the CEO. Somebody will CFO, somebody be marketing, somebody be developer, etc. So this is the idea. So inside Elasticsearch, if your cluster is very small, you each of the nodes will also be doing everything as well. So that's why we need to know what kind of things they need to do. The role list here is actually just a subset. So there are actually much more roles now. All right. But anyway, these are some of the common roles that probably you will kind of like encounter during your work life. So the first one is master eligible. So we've gone through this in the last lesson already. So master eligible nodes means that they can become the elector master. Okay. And then we have data nodes. Now data node is talking about like storage of data. When you search them, we help you to do the search. When you do aggregations, we help you to do the aggregations, etc. So that's data nodes. We also have ingest nodes. Now, ingest nodes is a very bad name. To be honest, I will rename it as script nodes. All right. So ingest nodes are the ones who's going to help you to do ingestion pipelines and painless scripts. All right. So if you want to do some do some pre-processing, like changing the formats of certain kinds of strings and so on, you need ingest nodes. So for the rest are some of the XPack related things. Sorry. So take example, if you have the corresponding XPack licenses, you can actually run a machine learning node so that they can run machine learning jobs. You can have something called transform node as well, so that you can transform the data into data frames if you want to. And then you can also have a remote cluster client who is useful for doing cross-cluster replications, all right? So the next few things that we need to know is we also have something called dedicated nodes as well. Now, to be honest, if you go to the YAML file, Elasticsearch YML, you should not see any node.xxx configurations because by default, all these rows are set to true. All right, so you'll be kind of like a startup founder. You'll be doing everything. So this node will also have all the kinds of roles available. But this is, again, not a very good idea. So later on, we'll explain why, right? So that's why, on the other hand, if you want to remove some capabilities, you should add back the node.xxx and set to false, all right? So again, it's kind of like some further explanations, right? Now, data nodes are important because they hold the shard that contains all the documents you have indexed. Sorry, it's a little bit something like that. So that means it's a data storage. They store all the data that you've ingested. And the next thing is it executes the searches for us as well. And of course, your aggregations are also handled by data nodes. And the important things is all the nodes have data nodes capability at the beginning, unless you set it to false, right? And the corresponding setup is node.data. You can toggle on and off if you want to. So data nodes help us to do the scaling as well. So data nodes are usually the ones with the better I/O, better CPU, memory, that kind of configuration machines, so that they can ingest the data as quickly as possible. All right. And why we say data nodes can scale? Because based on number of shards that you have, you can expand those shards to work in individual machines. That is the nodes. So that means the more shards you have and more data nodes you have, assume we can spread the ingesting traffic and workload to different nodes at the same time. All right. So it's kind of like spreading out and run parallel ingestions. So what about ingest nodes then? Now, ingest nodes, like what I said, should be renamed as something like script nodes. The reason is because if you want to do pre-processing, you need the ingest nodes, all right? Because they are the ones that's going to run it. And by default, all the nodes also have ingest nodes capability as well, all right? And we will talk about the ingest nodes and the capabilities, like using the pipelines, using the scripts in Engineering 2 instead. So for now, just understood that if you want to run these kind of additional things, you will need to have a ingest node. Machine learning nodes, on the other hand, is again some expect features. You will need expect licenses to run machine learning jobs. And if you have that license, you will be able to set individual machines to just do machine learning things. And the corresponding setup is based on Nook.ml. Now, one important thing is machine learning job is actually run by C++ programs. So even though we said that Elasticsearch is a Java program, the corresponding things that can be done through machine learning is actually not much. So we're using a C++ library to run these machine learning jobs and discoveries and etc. So that's why I would say if you have a machine learning node also dedicated, you should set less JVM heap, because we actually do not use Java to do the calculations. We're using C++. Okay, so just to let you know. There's a special node type called coordinating node as well. So coordinating node is, by default, all nodes will have this capability, and you cannot turn it off. So that's why there is no something called node.coordinate or node.client, no such thing. So you cannot toggle off. So it's always there. So then what's a coordinating node? Now, based on this graph here, you can see that node 2 got a request. So this node 2, once got the request, it becomes a coordinating node at once. It will start to coordinate what? The first thing, what kind of request are you talking about? Are you doing a search? Are you doing aggregation? I need to know. After knowing that, we will start to look, okay, so you're doing a search, for example. So you're involving this index, and this index has shots on node 1 and node 3 only. So I'm going to ask node 1, node 3 to handle the search for me. So this is the coordinating job that this node 2 has to do. So it's like a kind of like, it's kind of like managers, right? When you're doing projects with other companies or other teams, the manager is the one who's going to represent your whole team. And so he or she will just get the order, and then later on, he will come back and tell you guys to, hey, now Peter, how me to do this, Muhammad, do this, Julie, do that, all right? And so this is the coordination. So that's why for node 2, it's kind of like a manager. It coordinates the other nodes to work for it, all right? And finally, when the results come back, node 2 needs to recompile or maybe to process the final response that is suitable for the client to receive. So that's another coordinating job here. So this is the idea about coordinating node in general. Now remember, this role is not removable. Every node that is going to receive a request will change into a coordinating node at once. All right, so it's kind of like a transition. Suddenly change the context. And after finishing this coordinating job, it goes back to its own roles. Like for example, dedicated master or dedicated data, etc. So sometimes we said that coordinating node is kind of like load balancing. The reason is because once you send the request to a particular node, it knows how to spread out the workload. All right, it won't be the one who's going to do everything. For example, your manager won't be so stupid, right? So if somebody tells him or her to do something, he will not do everything. Instead, he will coordinate the other team members to work for him or her. So that's the normal situation for coordinating node. All right, so it won't be the one doing everything. Instead, coordinate, spread workload, and then do the final consolidation. So that's why we also say that coordinating nodes are kind of like load balancers. All right. So like this slide said, if you can, your clients should not be sending only to one IP address. All right, you should be sending to different NOC address in a round robin way, at least. All right. So like the question just now, should we send the send the logstash request to only one IP? So my answer is, if you can, send it to various IPs. All right. The reason is because we do not want, like for example, NOC 4 to be the one who's always working. We want other NOCs to work for us as well. All right. So what's the point? For example, in a company, what's the point to have only one person working while the others are sitting there doing nothing? So we should spread the workload. So that's why we should be round robining the IP addresses. Right. So that's the ideal way. Also, another reason why we should not be using only one IP address is, if NOC 4 offline, then your pipelines is dead. All right. You should also set up something like a backup. So if NOC 4 is offline, at least we still have NOC 5 working. So there should be multiple addresses. All right. And for Logstash, I've already sent you the link, so you can actually set multiple address for that. All right. Yeah. So that destination node is kind of like coordination node at that time. Right. So once it received, it will be coordination node, and after the handling and nothing comes in, or no job for it, it will goes back to its original roles. Yeah. Yeah. So that's it. So exactly like a normal human. So if I were the CEO of a company, if somebody suddenly comes to phone and say, hey, your system is offline, okay, I can temporarily become the support as well if I want to. Or maybe I just dedicate to somebody to be the support guy. All right. So the same thing. So after I finish this support call, I would just go back and say, oh, I'm still the CEO, something like that. All right. So that's the idea. It's a temporary switching. Yeah. So another concept is something called sniffing. Now, sniffing means what? Now, if we continue the scenario just now, right? Assume that you only have set one IP address, something called NOC 4, and you do not know there's actually NOC 5, 6, and 7 available. Assume you do not know this. Then, when NOC 4 is offline, your pipeline is gone because the only point inside that cluster is offline now. So you cannot proceed. All right. So one of the technologies that our language clients support is something called sniffing. Now, sniffing means what? If you are connected to NOC 4, we will sniff the network and get a bunch of possible available IP addresses as well. So if this NOC 4 is offline, we can try this set of IP, continue the pipeline. All right. So this is actually a good thing, because every time when there's a NOC offline or online, we do not need to restart our client. If not, you need to change the configuration, restart the client, and then we reconnect to the pipeline. So this is the idea why we have sniffing. And remember, sniffing is only available in language clients, which means if you're writing your own programs, like take example, you're using Java, you have the high-level REST APIs library, then you can run sniffing because we provide that. And if you're running by your own, for example, you're writing your own JavaScript using Ajax or maybe just using jQuery, you might need to do this kind of sniffing by yourself, all right? Because they're not directly support unless you're using the language clients like the Node.js client, all right? So just to let you know. So this is actually quite useful as well, because no matter you're using our libraries or not, or you're writing your own, you should also be able to have a backup so that you can reconnect without restarting your own programs, right? Some sample architectures, right? Usually we start with a one node cluster. So that's actually fine, as well as, as long as you're doing development, it's okay. But when we're going to production, one node cluster is not good because that's single point failure. Also, it doesn't scale, right? You cannot suddenly say, hey, a lot of requests come in. Can I scale the capability? The answer is you can't, because you only got one node. So then what about a two node cluster? in the old traditional way, two-node cluster is the only solution because like WebLogic, we only have 2 nodes. But in Elasticsearch, two-node cluster is not a good idea, nearly a bad design. The reason is because there is no quorum. So remember, quorum means half of the master eligible nodes plus 1. So in a two-node cluster, what is the half number? Exactly 1 node. Plus 1 means what? 2 nodes. That means if you have a two-node cluster, if one of them is offline, you do not have a quorum. And so your cluster will be offline. So that means totally a bad decision. And so that is the reason why we tell you that for production cluster, at least 3 nodes. All right? No matter what, at least 3 nodes. And 2 nodes is never a good design for Elasticsearch. And usually for a small production cluster, we should have at least 3 or maybe 5 nodes here. And you can start to see that we have some dedications. Now, out of the 5 nodes, we should have 3 of them master eligible, so that we have a backup for the ones to participate in any elections when needed. All right. And of course, one of them should be the elected master eventually. And then what about the other nodes? So the other nodes probably should be data nodes in general, because we will be storing data inside Elasticsearch. All right. Also, because the cluster size is so small, you should be able to see that the master nodes also has data capability. All right. Now, again, in a small startup company, what's the point to have single delegation? All right. Like, for example, if my company only contains 5 person, so what's the point to say I'm CEO, somebody CTO, and only 1 person doing the development? So probably all of 5 of us will be doing development, writing programs, doing support at the same time. All right. So that's the point here. So probably for a small cluster, you should have some of the nodes having multiple roles, like master and data at the same time. So on the other hand, the rest of them will be just doing some dedications like data only nodes or data plus ingest nodes. All right. What about some larger clusters then? So when we talk about larger cluster, at least 10 nodes, right? When you are growing into something like 10 nodes or above, you might want to think about dedication. Now, you really have only some machines doing master eligible, some machines doing just data nodes. And the corresponding setting is to go back into the YAML file, set the node.x66 to true for the ones that you're expecting to have. For example, the first 3 nodes, we're setting node.master true, and the rest of the node.x66, we set them to false. So this is a dedicated master node. So here, we're not listing everything, because if you still remember, we've got like 6 or 7 rows, right? We should actually add node.ml to false, machine learning, node.transform to false as well. Also, I think it's remote cluster client to false as well. So you should also set all these to false, all right, except node.master is true. So that's what we call dedicated master eligible node, all right? And so for the next remaining nodes, we might set node.data to true, right, while the others are false. So that's how we do dedication. So this kind of topic, we will actually go into them when we talk about hot warm architectures later on as well. So all these things we'll cover in Engineering 2. So for now, I will just stop here, right? Okay, I'll skip a summary because it's just really talking about the node roles and the corresponding characteristics and so on. All right, so how will you configure a node to be dedicated data node? Remember, go to the YAML file, node.data must be true. For the others, set it to false, all right? And since it's a static configuration change, you will need to restart your node as well. So if you don't restart the node, nothing will be realized, all right? So that's another concept. Number 2, true or false? A 2-node cluster is a good option for production cluster. You can try, but it's false, all right? We actually will require you to have 3 master nodes, all right, at least. So you need to have 3 nodes for a cluster in a production environment, all right? I'm not sure about the policy, but in the past, if you have a 2-node cluster or 1-node cluster for production, we typically do not support that. All right, so you can buy the license, but we will say, because you're less than this number, we don't responsible for any action that you do. All right. So you need to have at least 3 nodes. Number 3, larger high volume clusters should have dedicated nodes. Usually, yes. All right, because we want to dedicate certain machines just for ingesting, certain machines just for doing ingestion. The script nodes. Some others are just doing machine learning, etc. We want dedication. It's just like a company getting bigger. We want dedicated teams to do something instead of everybody do the same thing. All right, because we're not factories. So that's the point. All right, so today we'll end here a little bit early, so probably like 38 minutes before the ending of this class, but it's okay. So we just kind of like have an early release today. So tomorrow we will be covering the remaining classes, talk about understanding shards, and also we'll start to go to talk about the module 6, something like miscellaneous things, like for example, before you go to production, what kind of things should you concern? All right. So we'll be covering all those things. And tomorrow, probably we also have a earlier release as well. So now you can keep on doing your labs, or you can just do whatever you want because it's your time now. All right. So we'll continue tomorrow at the same time. That should be 8:30 Jakarta time, I think. All right. So see you.